Hi everyone, I am N.R. Bhuvaneshwari, Associate Professor, Department of Mathematics, SNS College of Technology. Today I deliver a case study on application of matrices. Matrix. The definition of matrix is a matrix is a rectangular array of number of other mathematical objects for which operations such as addition, subtraction and multiplications are defined. Application of matrices. Application of matrices are found in most scientific fields in every branch of physics, including classical mechanics, optics, electromagnetism, quantum mechanics, and quantum electrodynamics. They are used to study physical phenomena such as the motion of rigid bodies. Now, let us use that real life application using the concept of design thinking. Okay, before that, let us know about what is design thinking. Design thinking is a non-linear iterative process which seeks to understand users, challenge assumptions, redefine problems, and creative, innovative solutions to prototype and test. Here I describe the five stages of design thinking. First step 1 empathize, step 2 define, step 3 ideate, step 4 is the prototype, finally it's come to the test. The concept of using the concept of design thinking, explain the suitable solution for the application problem as given below. Suppose that we have a population of humans and zombies. We'll check in on them every few days. What is the worst that can happen? Suppose that every human has an 80% of chance of surviving those few days and 20% of chance of turning into zombie. Thankfully, the human aren't completely defenseless. They have found a cure. Unfortunately, it is very difficult to apply the cure. So every zombie has the 99% of chance of remaining zombie and 1% of chance of actually being cured. Find a possible solution for this assumption. This is our problem. Now we are using the concept of design thinking for this particular problem. Our guess is the application of matrices and gets used more than other or probably Markov chains. First we go to the empathy part. We define and understand the given ratios to be pretty sure that humans survive at the last. Define. To understand the given assumption and narrow down the equation in a matrix form which on further process can be solved by using algebraic properties. Ideate. Let us write the information down in the matrix. We define the matrix as 0.8, 0.2 in the first column. The addition should be equal to 1. The same thing we arrange in the column wise. In the second column is 0.01 and 0.99. The addition of these two also becomes 1. Here why this is useful? If we write the number of humans as HH and number of zombies is ZZ as a vector, now we can define that H, Z, H, Z. Then multiplying by the above matrix will exactly tell me how many humans and how many zombies we should expect in a couple of days. Prototype. For instance, suppose that we start with 1 zombie and 99 humans and check back in 2 days. Well, now we define the matrix. Just I've taken that above matrix what we have defined already, and we have one more column matrix is 99 1 in terms of column wise, which is equal to in terms of multiplication we get an array 79.21 20.79 in terms of column wise. What if we check back another 2 days? Well, we define that matrix. Again, we have taken the matrix A as it is and we got the solution in the last step, that is 79.21 20.79. Now after the multiplication we are getting that answer is 63.58 and 36.42. We arrange that in terms of column wise. 12. What we have shown in that number of humans and zombies after 2 days will be, just we put it in the matrix to the power n. Again 99 1. We define human as k, zombies as z. Let us work with linear algebra. We have taken the same matrix and we put the solution form in terms of A inverse, then which is that form A power n and this matrix to the power n, but since and another matrix to the power 1. So we get 1 0 0 0.79 whole power n implies 1 0 0 0. Now it's get that large matrix, we multiply over that, again gets closer and closer to the matrix on the another side. That is, we follows that matrix is 0.8, 0.01, 0.2, 0.99 whole power n is implies, just we define that matrix what we have defined in the last step. Thus we start that 999 humans and 11 zombie. Expectation is that after a long period of time we'll have that matrix representation of 0.05, 0.95 in terms of column wise. Wherever you can see, in addition of these two answers becomes 1. The same thing we have arranged in the second column is what we have got the previous solution is the 0.05 and 0.95. And we arrange the one more column matrix is 99 1, which is approximately we get 4.76 and 95.21. That is about 55 humans and 995 zoomies. The good news is that the humans survive. The bad news is that they only just barely survive. Okay, naturally, zombies aren't very real life, but spread of genes through a populationist, the Morgo chains can be applied to that perfectly well. Figuring out how to weigh different websites based on how many other sites linked to them can also be modeled as the Morgo process.